Chapter 3.3, the Factor Theorem. The Factor Theorem states that when a polynomial p of x is divided by x minus a and the remainder is 0, then x minus a is a factor of p of x. Determine if x minus 1 and x plus 3 are factors of p of x equals x to the power of 3 plus 2x squared minus 5x minus 6. We can use the remainder theorem from chapter 3.2. We know that if we sub in the a value into our p of x, then the result is the remainder of dividing p of x by our x minus a. So in the first case, we would have a equals 1. Let's sub in 1 into p of x, so p of 1 equals 1 to the power of 3 plus 2 times 1 squared minus 5 times 1 minus 6, which is 1 plus 2 minus 5 minus 6, which is 3 minus 11 is negative 8. So according to the factor theorem, it says if the remainder is 0, then x minus a is a factor. So since our remainder is not 0, then we would say, therefore, x minus 1 is not a factor of p of x. For x plus 3, our a value would be negative 3, since this is x minus negative 3. So sub in negative 3 into p of x. We have negative 3 in brackets cubed plus 2 times negative 3 in brackets squared minus 5 times negative 3 minus 6, which gives us negative 27 plus 2 times 9 plus 15 minus 6. Negative 27, 9 and 9 is 18, so plus 18, and then 15 take away 6 is 9, so plus 9. 18 plus 9 is 27, so we have negative 27 plus 27, which gives us 0. So our remainder is 0. Which, according to the factor theorem, tells us that x plus 3 is a factor of p of x. The integral zero theorem. In a polynomial function with a leading coefficient of 1, the potential factors are found from the factors of the constant term. If x minus a is a factor of p of x with integral coefficients, then a is a factor of the constant term of p of x. Example, what is the factored form of x cubed minus 4x squared minus 11x plus 30? How can you use the graph of the corresponding polynomial function to simplify your search for integral roots? For our integral zero theorem, we have a polynomial with a leading coefficient of 1. This would be 1x to the power of 3, so leading coefficient of 1. Then it says the potential factors are found from the factors of the constant term. Our constant term of p of x is 30. So factors of 30 would be plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 6, plus minus 10, plus minus 15, and plus minus 30. Positive or negative, 1, 2, 3, 5, 6, 10, 15, and 30 can all divide positive 30. So we could go about just testing those numbers by using the factor theorem and subbing them in to p of x to see if we get a remainder of 0. But there's quite a few to test there. So how can we use the graph of the corresponding polynomial function to simplify your search for integral roots? Let's graph this polynomial. We have x to the power of 3 go out of my exponent, minus 4x squared minus 11x plus 30. Graph that, and here's what we get. So when we get a remainder of 0 using the factor theorem, so we plug in our a value and we get a remainder of 0, that means that the function is equal to 0 at that x value, so that's an x-intercept. So what we do to narrow down our search, instead of testing all of these possible factors, which would be a lot, we can look at our graph and find even just one x-intercept is all we need. So find one x-intercept using your calculator. You can do that here. Second trace. Number 2, we just need one of them. So I'm going to find this one here. So left bound of that x-intercept, hit enter. Right bound of that x-intercept, hit enter. Hit enter again. It's at x equals to 2. So we sub in 2 for our x value. P of 2 equals 2 to the power of 3 minus 4 times 2 squared minus 11 times 2 plus 30. We calculate that. I'm just going to do it on my calculator. Exit, clear. We have 2 to the power of 3, get out of my exponent, minus 4 times 2 squared minus 11 times 2, and then plus 30, which gives us 0, which is our remainder. Therefore, x minus 2, if we take the a value of 2 and put it back into the general form of our binomial divisor, which is x minus a, then it becomes x minus 2, is a factor of p of x. We want the factored form of p of x, so we know now that x minus 2 is a factor. So let's divide p of x by x minus 2 using either long division or synthetic division. I'm going to do synthetic division. The coefficients are 1, negative 4, negative 11, and 30. We have our L shape. We're dividing by x minus 2, so we put minus 2 here. We drop down the first coefficient, so 1. We multiply the outside. Negative 2 times 1 is negative 2. We subtract inside. Negative 4 minus negative 2 is negative 4 plus 2, which is negative 2. Negative 2 times negative 2 is positive 4. Negative 11 subtract 4 is negative 15. Negative 2 times negative 15 is positive 30. 30 subtract 30 is 0. Then we can write p of x as p of x equals x minus 2 times the trinomial x squared minus 2x minus 15. So remember, this is our remainder. This is our constant. This is our x term. This is our x squared term, and so on. So we get the trinomial 1x squared minus 2x minus 15. And then we can factor the trinomial. To get the fully factored form of p of x equals to x minus 2 times. We need two numbers that multiply to negative 15 and add to negative 2. Those would be negative 5 and 3. So x minus 5, x plus 3 would be our factors. And our fully factored form of p of x is x minus 2 times x minus 5 times x plus 3. What is the fully factored form of x to the 4 minus 3x to the 3 minus 7x squared plus 15x plus 18? Factors of the polynomial must be found in. This has a leading coefficient of 1x to the 4. So using the integral zero theorem, we look at the constant term of the polynomial, which is 18, and we find factors of 18. Which are plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 9, and plus minus 18. Any of those values can divide 18. Use the factor theorem to find a factor. There's a lot of numbers here to test, so before we even do that, let's cheat the system and use our graphing calculator to find the x-intercepts. We have x to the power of 4, move out of the exponent. Then we have minus 3x to the power of 3, move out of the exponent, minus 7x squared plus 15x plus 18. And here we go. So find one of the x-intercepts. It doesn't matter which one. I'm going to find this one, second trace number 2, left bound of this x-intercept. So down here somewhere, hit enter, right bound up there somewhere, hit enter, hit enter. So negative 1, 0. And then I can pretend that I used the factor theorem by doing this. P of negative 1 equals negative 1 in brackets to the power of 4 minus 3 times negative 1 in brackets to the power of 3 minus 7 times negative 1 in brackets squared plus 15 times negative 1 plus 18, and then calculate that. We have negative 1 to the power of 4 minus 3 times negative 1 to the power of 3 minus 7 times negative 1 squared plus 15 times negative 1 plus 18. There we go, we get 0. P of negative 1 equals 0. Therefore, x minus a, so x minus negative 1, which is x plus 1, is a factor of p of x. Use synthetic division to find another factor. Our coefficients are 1 minus 3 for the x cubed term, minus 7 for the x squared term, 15 for the x term, and then 18 as the constant. Our L shape, we are dividing by x plus 1, so plus 1 on the outside, bringing down our first coefficient. We're multiplying outside. 1 times 1 is 1. We're subtracting inside. Negative 3 minus 1 is negative 4. 1 times negative 4 is negative 4. Subtracting. Negative 7 minus negative 4 is negative 7 plus 4 is negative 3. 1 times negative 3 is negative 3. Subtracting. 15 minus negative 3 is 15 plus 3, which is 18. 1 times 18 is 18. 18 minus 18 is 0. That's our remainder, constant, x term, x squared term, and x cubed term. So then we can write p of x as x plus 1 times the remaining polynomial x cubed minus 4x squared minus 3x plus 18. So we can use the integral factor theorem again. We can also use our graphing calculator to find another one of our x values. Graph, let's find another x-intercept. I'm going to find the one on the farthest left, second trace number 2. Left bound of that point would be up here. Enter. Right bound of that point would be down here somewhere. Enter. And it tells me that it's negative 2. This remaining polynomial, that's our quotient, so we'll call it q of x. Then q of negative 2 would equal 0, since negative 2 was an x-intercept of p of x. Therefore, x minus negative 2, or x plus 2, is a factor of q of x. Next, it wants us to factor the remaining polynomial. So if we take q of x, which is x cubed minus 4x squared minus 3x plus 18, and divide that by the factor that we determined above, that was x plus 2. I'm going to use synthetic division again. So q of x, the coefficients are 1 for the x cubed term, negative 4 for the x squared term, negative 3 for the x term, and 18 as the constant. Our factor is x plus 2, so plus 2 here. Drop down the first coefficient, and then multiply. 2 times 1 is 2. Subtract inside. Negative 4 minus 2 is negative 6. 2 times negative 6 is negative 12. Subtract. Negative 3 minus negative 12 is negative 3 plus 12, which is 9. 2 times 9 is 18. Subtract 18 minus 18 is 0. That's our remainder, our constant, our x term, and our x squared term. So then we get the trinomial 1x squared minus 6x plus 9, and we can factor that. Two numbers that multiply to 9 and add to negative 6 would be negative 3 and negative 3. So x minus 3, x minus 3. Then p of x, our original polynomial, when fully factored, would be x plus 1 times x plus 2 times x minus 3, or x minus 3 squared. Rational zero theorem. In a polynomial function with a leading coefficient other than 1, the potential factors are found from taking the factors of the constant term and then dividing those by the factors of the leading coefficient. Example, find the potential possible zeros of P of x equals 5x cubed minus 51x squared plus 55x minus 9. We want to look at the factors of the constant term, which is negative 9. So plus minus 1, plus minus 3, and plus minus 9. And then divide those by the factors of the leading coefficient, which is 5. So plus minus 1 and plus minus 5. Then our possible zeros would be plus minus 1, because if we have 1 divided by 1, we get 1. Plus minus 3. Plus minus 3 divided by plus minus 1 would give us plus minus 3. And plus minus 9. Same thing. Plus minus 9 divided by plus minus 1 gives us plus minus 9. And then we also have plus minus 1 over 5. Plus minus 3 over 5. And plus minus 9 over 5. Fully factor 3x cubed minus 4x squared minus 17x plus 6. Our possible zeros would be factors of our constant term, which is 6, divided by factors of our leading coefficient, which is 3. Plus minus 1, plus minus 2, plus minus 3, and plus minus 6 on top, divided by plus minus 1, plus minus 3, which gives us plus minus 1, plus minus 2, plus minus 3, and plus minus 6 if we divide by 1. And then 1 divided by 3, so we'd have plus minus 1 over 3. 2 divided by 3, plus minus 2 over 3. 3 divided by 3 is 1, which we already have. We have plus minus 1 in our factors, so we don't do that one. And then plus minus 6 divided by plus minus 3 would give us 2, which we already have. So this would be the list. Then we want to graph and find one x-intercept. Let's do that. Clear this. We have 3x to the power of 3. Move out of the exponent, minus 4x squared minus 17x plus 6. Graph that. Let's find one of our x-intercepts, doesn't matter which one. Second trace, number 2. I'm going to do the one on the far left. So left of that x-intercept would be below it, enter. Right of that x-intercept would be above it, enter. And it tells me that it is negative 2. So then P of negative 2, which equals 3 times negative 2 to the power of 3 minus 4 times negative 2 squared minus 17 times negative 2 plus 6. We'll double check to make sure that that equals to 0. It should. 3 times bracket negative 2 close bracket to the power of 3 out of the exponent minus 4 times bracket negative 2 close bracket squared minus 17 times negative 2 plus 6, and we get 0. P of negative 2 equals 0. Therefore, x minus negative 2, which is x plus 2, is a factor of P of x. Next, we want to divide p of x by x plus 2 in this case. That was the factor we just found. Using long division or synthetic division. Again, I'm going to use synthetic. Our coefficients are 3, -4, -17, and 6. We're not missing any. We have x cubed, x squared, x, and then constant. Draw the line. Our factor is x plus 2. Drop down the first coefficient. Multiply. 2 times 3 is 6. Subtract. -4 minus 6 is -10. 2 times -10 is -20. Subtract. -17 minus -20. -17 plus 20, which is 3. 2 times 3 is 6. Subtract 6 minus 6 is 0. So that's a remainder of 0, a constant of 3, x term of -10x, and then the x squared term of 3x squared. Then we can factor our remaining trinomial. (3x squared minus 10x plus 3). There's no common factor, so this is a complex trinomial. We multiply a times c. 3 times 3 is 9. We want two numbers that multiply to give us 9 and add to give us -10, which would be -9, -1 multiplies to +9. -9 minus 1 is -10. Do the box method because it's a complex trinomial. First box is 3x squared. Bottom right box is our constant term of 3. The other two boxes are -9x and -1x. Common factor each row and column. First row, 3x squared -9x is 3x. Second row, -x and 3 is -1. It's a negative because the first term in the row is negative. First column, 3x squared and -x would be x, and second column, -9x and 3 would be -3. It's negative because the first term in the column is negative. Then we would get 3x minus 1 times x minus 3 is the factored form of our trinomial. The factored form of our polynomial p of x would be x plus 2, our first factor, times 3x minus 1 times x minus 3. A form that is used to make large rectangular blocks of ice comes in different dimensions, such that the volume V in cubic centimeters of each block can be modeled by V of x equals x to the 3 plus 7x squared plus 16x plus 12, where x is in centimeters. Determine the possible dimensions in terms of x that result in this volume. Volume for a rectangular prism is length times width times height. So we want to factor our polynomial to write it in terms of 3 factors, which will be the length, width, and the height. Starting with our possible zeros. The leading coefficient is 1, so we're just looking at factors of the constant term. Constant term is 12. So plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. Then we want to find one of those that will give us a remainder of 0. So we cheat the system and we use our graphing calculator so that we don't have to test them all. So we have x to the power of 3, move out of my exponent, plus 7x squared plus 16x plus 12. Graph that. Here's what we get. Let's find one of our x-intercepts. Second trace number 2. We need to do the one on the far left. So left bound of that point would be down here. Hit enter. Right bound would be in between the two x-intercepts. Hit enter. And it tells me that x equals to -3. So I plug in -3 into our polynomial. V of -3 equals -3 in brackets cubed plus 7 times -3 in brackets squared plus 16 times -3 plus 12. And we should get 0 because it's an x-intercept. -3 in brackets to the power of 3, move out of my exponent, plus 7 times -3 in brackets squared plus 16 times -3 plus 12, and we get 0. V of -3 equals 0. Therefore, x plus 3 is a factor of v of x. Let's divide v of x by the factor x plus 3. I'm going to use synthetic division again. The coefficient on x cubed is 1. Coefficient on x squared is 7. Coefficient on x is 16. And the constant term is 12. To our L shape, we're dividing by x plus 3. So plus 3 is outside here. Drop down the first coefficient, and then we are multiplying. 1 times 3 is 3. Subtract inside. 7 minus 3 is 4. 4 times 3 is 12. Subtract inside. 16 minus 12 is 4. 3 times 4 is 12. 12 minus 12 is 0. That's our remainder, our constant term, our x term, and our x squared. So we're left with the trinomial x squared plus 4x plus 4. We factor that trinomial. Two numbers that multiply to 4 and add to 4, x plus 2 and x plus 2. Then v of x in factored form is x plus 3 times x plus 2 times x plus 2. Therefore, the possible length, width, and height of the rectangular blocks are x plus 3, x plus 2, and x plus 2 again. That brings us to the end of Chapter 3, Lesson 3.